in the previous section, we took a look at the law of sines. So in this section, we're going to take a look at the law of cosines. And so the objectives of this lesson are to be able to use the law of cosines to be able to solve triangles, and then also to use Heron's formula, right, to be able to solve the area of a triangle. So let's first of all define what the law of cosines is used for. And similar to the law of sines, the law of cosines may be used to solve triangles, not necessarily right triangles. One of the best uses of the law of cosines is that we're given three sides but no angles. And unfortunately, with our law of sines, we can't solve those triangles because we have to have at least one angle to be able to solve those. So here's our formulas. If A, B, and C are the sides of a triangle, the law of cosines states that the angle A can be computed as a formula of sides, b squared plus c squared minus a squared over 2bc. Cos of b, a squared plus c squared minus b squared over 2ac, and cos c, a squared plus b squared minus c squared over 2ab. So let's prove one of these really quickly, okay, just to make sure that we understand where this comes from. So let's say I'm looking at the first quadrant, and for some reason I have a triangle that looks like this, okay? So let's call this B, okay, the side. I'm going to call this right here, let's call this angle C. Right? And then opposite of that is going to be C right here, right? And let's call this angle A, and let's call this angle B for some reason, okay? And we could draw a perpendicular right here if we elect to, okay? And let's call that the point, if this is going to be the point XY, okay? So let's say at angle A, there's also going to be that point X comma Y, right? This would be the point right here, X comma 0, right? Now, let's make sure that we can go through and be able to get the coordinates right here for this A, right? So if we use our law of sines, okay, and by the way, the height of this would be y, okay, since the height right here, if this is the coordinate x comma y, the height of that right triangle or that triangle would be y. And so we could say that by using our just basic definition of the sine of c, which is going to be the opposite over the hypotenuse, is y over b, or we get that b sine of c is going to be equal to y. And then also what we could do is we could try to find the cosine. So we know the cosine of c, which is going to be the adjacent over the hypotenuse. Now let's call this x because the distance from here to here is just the distance x. That's going to be x over b, or we could say b cos c is equal to x, right? So this point, instead of xy, we could write that as b cos c, comma, b sine c, right? Now, we could also use the Pythagorean identity because we notice that we have right triangles, okay? So the triangles CA, and if this was like another point D, okay, just so I could call it something, then CAD would be a right triangle, or CDA, excuse me, and ADB would be right triangles, okay? So let's just focus right now on the triangle that's a little bit smaller with respect to area. Okay, so let's take a look at this animal right here. And I could absolutely use the Pythagorean theorem to be able to find a relationship between our sides. Okay, let's call let's call this measure, and remember opposite, this whole measure right here is going to be A, all right, because it's opposite side angle A, right? And so this smaller measure would be A minus X, all right? Just because we already have X, we already have A, so the difference between them would be this smaller side right here. Right? So let's see if we can find some sort of relationship that might exist here, okay? And we certainly know that we have a hypotenuse and we have a couple legs, okay? So let's go ahead and plug those into the Pythagorean theorem, and we could say that c squared equals y squared plus a minus x squared. Okay, so a leg here and a leg here. Right? Now, if I FOIL this a minus x out, I get that c squared equals y squared plus a squared minus 2ax plus x squared. Right? But we just found x and y. Okay, so let's substitute x and y back in to this expression. So c squared is going to be equal to, if we square y, okay, so we're taking this expression right here and we're squaring it, that's going to be b squared sine square c. We still have the a squared. We have 2a times, we know that x is going to be b cos of c, right here, and then plus b squared cos square c. Now, notice that these two expressions contain a b squared in it. So I could factor those out, and I could get c squared equals b squared times the quantity of sine square c plus cos square c. And I still have the a squared and the minus 2ab cos c. We know that this is 1, okay, by Pythagorean identity. And so I wind up with c squared equals b squared plus a squared minus 2ab cos of c, right? And if I wanted to solve this for the cosine of c, okay, which is ultimately what I'm going to do, let me just erase this just a little bit so we get some room here. All right. What I'm going to do is I'm going to subtract b squared, I'm going to subtract a squared, and then I'm going to divide by that negative 2ab to isolate the cosine of c. All right, and then we can just perform a little bit of algebra on here. All right, so just hang tight, almost done erasing, just so we can clear out just enough room. So, so we have that this is going to be c squared minus a squared minus b squared divided by negative 2ab is equal to cos of c. Okay, so what I did was I just subtracted a squared and b squared, and then I divided by this coefficient to isolate cos of c. Now, if I divide by a negative, what that could do is I could just switch all the signs in the numerator. Okay, and so ultimately, if I do so, that becomes a squared plus b squared minus c squared divided by 2ab is equal to the cosine of c. All right, and I believe that's our formula. Okay, so check that out. That's exactly what we wanted to get. Okay, so the proof is a little bit rough for the law of cosines. All right, but that's how we would go through and try to prove, at least for the cosine of c, you could imagine that we could prove for any of these the exact same relationship. All right, so in the next video, what we're going to do is we're just going to implement the law of cosines to be able to solve some right triangles. We're probably going to use this in tandem with the law of sines to make it a little bit easier for ourselves.